Okay, let's talk about problem 907, sum of subarray minimums. What the question is asking, let's go through the example. It's going to be the easiest the way to find what's the question. They are gonna give you an array. You should find all subarrays, continuous subarrays. Find minimum of each one, add them up, and get the number. For example, here are all of the subarrays. The minimums of each subarray is listed here. Then the sum is 17. The brute force way to do it is gonna be the way that I have done it, which is find each subarray, find the minimum of that, and then add them up. But the issue is it's gonna give you time limit exceeded error. So it should be a better way to do that. The way that I'm gonna show you is with different point of view. So we are gonna see, for example, 3 is the minimum value for how many of these subarrays. Then let's say 3 is minimum of, just let's say, I know it's not correct, but let's say 3 is minimum value of 2 subarrays. Then 2 times 3 is gonna be 6. So the share of 3 is gonna be 6. I know it's repeated one time, but I'm gonna just assume I just said 2. Okay. Or just let's say 1. 1 is repeated 6 times, so it's the minimum value of 6 arrays. The value is 1. 6 times 1 is gonna be 6, so the share of 1 is gonna be 17. So basically, for each number, we are gonna see it is minimum of how many subarray. We are gonna times that value by the value of the number itself, and then do it for all the list and add them up. Okay, here is the example. Let's say we have this array. To make it easy, we are gonna add infinity, minus infinity to both left and right hand side. Then we are gonna find the left bound and right bound for each numbers. Right bound is we are gonna travel to the right to the number it's gonna get smaller than 3. Left bound, the same thing. We are gonna go to the left till we get to the number that is less than 3. So for example, for 3, here is the bound. Left bound minus, so the index of left minus the value itself is 1. The same thing on right. 1 times 1 is 1. Left times right times the value itself, which is 3. So the share of 3 is 1. For 1, the left bound is, here I need minus, okay, 2 on the left hand side, 3 on the right hand side. So the so 2 times 3 is gonna be 6. 6 times 1 is gonna be 6, and that's the way. So here is the key. The times a number of n occurs in the minimum is left boundary minus index times right boundary minus index. And then we should sum this this basically left times right times n. We are gonna add them up for all the values. Now the question is, okay, how do we want to find for each of these arrays, how do you want to find the right hand side or then the left boundary and the right boundary? That's a little bit tricky. This is where we are using monotonic stack here. Okay, so let me show you what I mean. Okay, let's see, where do I have it? Here, yeah. Basically, that lady is, I'm borrowing her idea. So we are gonna have a stack. So we are looping through the array, the whole array. So here is the start. She added infinity to both ends, then she'll start to travel. Each number she sees, she's gonna add it to the stack. However, if the number we see is less than the last value in the stack, we are gonna pop that value. And then for this popped value, here is the key. For this popped value, we know its right hand side boundary and its left hand side boundary. Let me put it again. Let me say it again. Let's say we are start traveling to this or looping through this loop. When we are at 1, we still don't know what is its right hand side. Or when we are at 3, we still don't know what is its right hand side. But when we went to 1, we are popping 3 from the stack. We know that 1 is the right hand side of the 3. Okay, what is the left hand side of the 3? The last number that is still in the stack it's going to be left hand side because we know it's smaller than this value and it's just next to that. So to give you an example, let's say here we start looping. First we are going to add infinity to a stack. So we are going to just put the index. I just put the value here for more clarity. We are going to put 0 or the value minus infinity to a stack. What's the next value? 3 or index 1. 3 is larger than minus infinity, so we are going to add it to the stack. But then we are going to get to 1. When we are going to get to value 1 or index 2, we know 1 is smaller than 3, so we should pop 3. Okay, when we are popping 3, what do we know? We know its right hand side value is going to be 1. Its left hand side, okay, here is the thing. Yeah, so we popped it, we are going to pop it, so we are going to know its right hand side is going to be the current value, these ones. What's the left value? So when we pop this one, this is going to be the left hand side of that. So that's what we already have in a stack. So if we times these two, it's going to be 1 times 1 because of its value, it's going to be, so okay, I minus current minus last item in the stack times the value itself. Yeah, so right hand, so this is left hand side, this is the right hand side, and we are gonna add them up. The good thing is with infinity at the minus infinity at the right, we know that we are gonna pop all the numbers. One tricky thing is here, they didn't put equal, they put if it's more than that. That's an interesting one. And then because the question is saying, okay, put it in this format, this is how it has been put there. Okay, I think that's it.